Hello students, today I am going to introduce continuity and differentiability and explain you how do we solve the questions based on continuity and differentiability. It's an important part of calculus, so let us begin with that. First of all, continuity. It says that a function fx is continuous at x is equal to a if right hand limit is equal to the left hand limit is equal to the value of the function at that point. If the right hand limit is equal to the left hand limit is equal to the value of the function at that point. Now what is the working rule to calculate the right hand limit? If you have to calculate the right hand limit, it will be limit x tending to a positive if you are finding at point A, and the working rule says take limit h tending to 0 and substitute x as a plus h. So this is the working rule to calculate the right hand limit. Then comes what is left hand limit. This is written as limit x tending to a minus, a negative fx, which gives you limit h tending to 0 f of a minus h. Limit h tending to 0 f of a minus h. And if the result of right hand limit, the result of left hand limit and the value of the function at a, these three are equal, then we say that the function is continuous, otherwise the function is discontinuous. Now what is the working formula to calculate differentiability, whether a function is differentiable or not? We have to find out. A function fx is said to be differentiable if right hand derivative is equal to the left hand derivative. If right hand derivative is equal to left hand derivative at the point A. This can also be written as R f dash A, and this is L f dash A. The formula. Now how do we calculate the right hand derivative? The working rule says limit h tending to 0 f a plus h minus f a upon h. Limit h tending to 0, and then we have to substitute the value a plus h into the given function minus the value of the function at that point upon h. And for calculation of left hand derivative, the working rule is, the formula is limit h tending to 0 f a minus h. Here it is a plus h, here it becomes a minus h upon f a divided by minus h. And if both the values of the right hand derivative and the left hand derivative are equal, then we say that the function is differentiable at that point. So students, now let us see some questions based on continuity and differentiability. Again I will repeat, to find whether the function is continuous or not, we have to find out the right hand limit, left hand limit and the value of the function at that point. And to find out the differentiability, we have to find out the right hand derivative, the left hand derivative, and if they are equal, then we say that the function is differentiable at that point. So let us take a few questions which are very important questions, and they have been asked in exams very frequently. The first question, if fx is equal to mod x minus 1 upon x minus 1, where x is not equal to 1, and minus 1 where x is equal to 1. Discuss the continuity at x is equal to 1. Discuss the continuity of this function at x is equal to 1. So first of all, we'll find out what is the value of the function at 1. The value of the function at 1 is minus 1. That is already given to us. Now we find out the right hand limit of the function at x is equal to 1. So this will become limit x tending to 1 positive fx, which will be equal to limit h tending to 0 f of 1 plus h. So we have to find out the value at 1 plus h. We take up this function and substitute the values. So we get limit h tending to 0 modulus of 1 plus h minus 1 upon 1 plus h minus 1. You can see this gets cancelled, and this modulus of 1 plus h becomes 1 plus h. So we get limit h tending to 0 1 plus h minus 1 upon h because of this modulus. So this gets cancelled and we get 1. So here the value was minus 1, here the value is 1. They are unequal. So as the right hand limit is not equal to f of 1, so it's not continuous at x is equal to 1. See again, students, we have to take the point x is equal to a is 1. So first of all, we find out the value of f1, which is already given as minus 1. Then we find out the right hand limit at 1. So we take this function and find out the value at 1 plus h. So limit h tending to 0 modulus of 1 plus h minus 1 upon 1 plus h minus 1. This simplifies to 1, and hence we say that right hand limit is not equal to f of 1. Hence it is not continuous at 1. Now we take up second question, which says that fx is equal to x squared plus 3x plus p, where x is less than equal to 1, and qx plus 2, where x is greater than 1. Find the value of p and q. Find p and q if fx is differentiable at x is equal to 1. See the question again. Fx is equal to x square plus 3x plus p, where x is less than equal to 1. Qx plus 2 when x is greater than 1. Find the values of p and q if fx is differentiable at x is equal to 1. The most important thing you must note over here in this kind of question, if a function is differentiable, then it is also continuous. So as fx is differentiable, so it's also continuous. So first of all, we are going to use the concept of continuity, and then we are going to use the concept of differentiability. See again, the important note is that as fx is differentiable at the given point, so it is also continuous at that point. So firstly, we will say, according to question, right hand limit is equal to the left hand limit is equal to the value of the function at the point. So what is value of the function at 1? If we substitute 1 over here, we get 1 square plus 3 into 1 plus p. So that gives us 4 plus p. Now we have to take RHL as qx plus 2 is greater than 1. So we take RHL, we apply limit x tending to 1 positive fx, which is equal to limit h tending to 0 f1 plus h. Applying 1 plus h in this function, limit h tending to 0 q into 1 plus h plus 2. So that gives you, on applying the limit, q plus 2. Here we have got 4 plus p, here we have got q plus 2. Equate both of them. Equating this we get 4 plus p is equal to q plus 2, or we say that q minus p is equal to 2. So this is one of the equations we have obtained by using the concept of continuity. Now we use the concept of differentiability. Now right hand derivative is equal to the left hand derivative according to question. So we apply limit h tending to 0. We apply the formula of f1 plus h minus f1 upon h is equal to limit h tending to 0 f1 minus h minus f1 upon minus h. This is the formula of right hand derivative. This is the formula of left hand derivative. Now we substitute these values into the question. f1 plus h we have to apply where x is more than 1. Before I proceed, please see again. In the question, fx is given as x square plus 3x plus q, where x is less than or equal to 1, and qx plus 2, where x is greater than or greater than 1. So we apply these values into the question. Limit h tending to 0, f1 plus h we have to apply in this function, q times 1 plus h plus 2 minus f1 1 plus 3 plus p divided by h is equal to limit h tending to 0. Now we apply 1 minus h, so we have to apply over here 1 minus h whole square plus 3 times 1 minus h plus p minus f1. Again we apply over here 1 plus 3 plus p. It's a little lengthy question to solve, but it can be asked as a 4 marker. Simplify it now. This will become q plus qh plus 2 minus 4 minus p upon h is equal to limit h tending to 0. Open the brackets, 1 plus h square minus 2h plus 3 minus 3h plus p minus 4 minus p upon minus h. See if something gets cancelled, p gets cancelled. 1 plus 3 is 4, that gets cancelled with this 4. In this question, this q minus p, this value is given as 2. So substitute that value. Substitute q minus p as 2. So we get limit h tending to 0, q minus p as 2 plus qh plus 2 minus 4 upon h. So this values get cancelled, and on this side we are left with h square minus 2h minus 3h. Take h common, so you are left with h minus 5 upon minus h. See again, h square minus 2h minus 3h, h square minus 5h, h is common, this gets cancelled. From here also h and h will get cancelled. So I'll rub the other part so that we can follow from here. It's a long question, so need to. Now applying the limits, we get q is equal to, this will become 0 as minus 5. So we have got q value as minus 5. Put q value as minus 5 over here. So we get minus 5 minus p is equal to 2, minus p is equal to 7, p is equal to minus 7. See students, in this question we have to use the concept of continuity as well as the concept of differentiability to simplify. I hope you must have understood this question. So we'll take one more question. Let's take one more question which gives us a wider way that how to solve these kind of questions. Now, this question is, if fx is equal to root 2 cos x minus 1 upon cot x minus 1, where x is not equal to pi by 4. Find the value of f pi by 4 so that fx becomes continuous. Please see again. The question says, if fx is equal to root 2 cos x minus 1 upon cot x minus 1, where x is not equal to pi by 4, then find the value of f pi by 4 so that fx becomes continuous. So dear students, before I check up the LHL and RHL, I need to simplify this function. This function, root 2 cos x minus 1, this cot x I will write cos by sine, so we get cos x minus sin x upon sin x, which comes over here. So before simplifying it further, I will rationalize the numerator as well as the denominator. Rationalizing the numerator will give me 2 cos x plus 1 upon root 2 cos x plus 1. Similarly, with cos x minus 1, I'll rationalize using cos x plus sin x, cos x plus sin x. See again, root 2 cos x minus 1 we have rationalized by multiplying with root 2 cos x plus 1 upon root 2 cos x plus 1. Cos x minus 1 by cos x plus 1 and cos x plus sin x, cos x plus sin x. What happens with this? A minus b, a plus b will give you a square minus b square. So that these two will club together to get 2 cos square x minus 1. And these two will club together to give us cos square x minus sine square x. What are we left with? We are left with sine x into cos x plus sine x divided by root 2 cos x plus 1. These two clubs together to get 2 cos square x minus 1. These two are clubbed together to get cos square x minus 1. Sin x comes as it is. Then we are left with cos x plus sin x upon root 2 cos x plus 1. So in this question you have seen that we need to rationalize the numerator as well as the denominator. So this is 2 cos square x minus 1 is same as cos 2x, and this is also cos 2x. So these two terms gets cancelled. Now sin x, how can you write cos x plus sin x? Cos x plus sin x can be written as sin pi by 4 plus x. Now I'll have to find out the right hand limit for this function. I'll have to find out the left hand limit for this function. Whatever both the values will come, that will be the value of f pi by 4. Is that clear? So we take up RHL for this function now. It will be limit h tending to 0 sin pi by 4 plus h. In this case it will become sin pi by 4 plus pi by 4 plus h upon root 2 cos pi by 4 plus h plus 1. See again, it has become sin pi by 4 plus h into sin pi by 4 plus pi by 4 plus h upon root 2 cos pi by 4 plus h. This is sin 90 plus h, and in this I have to expand. Sin pi by 4 plus h. You can do it in rough and find out the value, because otherwise it becomes too lengthy to solve over here. Sin pi by 4 plus h. Use the formula sin a cos b plus cos a sin b. Sin a cos b plus cos a sin b. This is 1 by root 2 cos h, and this is 1 by root 2 sin h. So 1 by root 2 cos h plus 1 by root 2 sin h. This becomes cos h. This will become cos pi by 4 plus h. Use the same identity. Cos a cos b, cos a cos b minus sin a sin b. So that will become 1 by root 2 cos h minus 1 by root 2 sin h plus 1. Now when you apply the limits, this becomes 0, this becomes 0. So what will you left with? 1 by root 2, this is 0, this is 1. When you apply the limit here, root 2, this is 1 by root 2, this is 0, and this is plus 1. So you get 1 upon 2 root 2. See again, students, if you remember the value, you can go ahead directly also, but I have solved it for you. How to get sin plus pi by 4 plus h value, how to calculate cos pi by 4 plus h value, then substitute the values and then apply the limits into this question. As it was already given that the function is continuous, so there is no need to find LHL, and hence we can say that f of pi by 4 should be 1 by 2 root 2. Before I end, let me explain it again to you. two important steps in this question. Number one, rationalizing the numerator as well as rationalizing denominator. Then this becomes cos 2x, this becomes cos 2x, cancelling it out, and then applying this identity, cos x plus sin x is sin pi by 4 plus x, and then you find out the right hand limit. In between that, you have to find out the value of sin pi by 4 plus h and cos pi by 4 plus h, and hence we get that f pi by 4 is equal to 1 by 2 root 2. So these three questions which we have done, they are the very important questions, and must keep on doing these kind of questions as a preparation for CBSE exams. Thank you, students, and keep subscribing to our channel Ashish Singhal #maths, and we'll be uploading more videos with more solutions.